In this video, we're going to look at solving simultaneous linear equations with two unknowns using 2 by 2 matrix. This time around, we shall be using inverse method. There was a video I did, I shot that it's almost similar to this, what we're going to do in this video. But that video, we looked at how to solve simultaneous linear equations with two unknowns simply using 2 by 2 matrix. But this, in that video, I told you that there's also another method. I was referring to this method. So in this video, we are going to use the inverse method instead to solve the simultaneous equation. So if we have the equation in this form, ax plus by equals to c, dx plus ey equals to f, the matrix form of this simultaneous equation is this part, where a, b, d, e times xy. So our xy becomes our column matrix, and then what we have here becomes our square matrix. This is the 2 by 2 matrix. So which means a times x gives us ax, and then b times y gives us by equals to c. When you equate entries or rows, then d times x will give us the x, and e times y equals dy equals to f. So then the solution will become we get this person. How we got to this point is, remember, if we have let's say x y is equals to e, and you want to get the value of x, or let's say you want to make x the subject formula, you remember that you're going to divide both sides by y, so that x will be here and you have e over y. And another way to write this is x equals to 1 over y times e. And from indices, you know, from indices, 1 over y is equals to y inverse y raised to the power of minus 1. So this will give us y minus 1, or you can write it as x equals to a y minus 1. So that's exactly what happens here. So when you have a, b, d, e, and x, y, c, f, we want to make xy our subject formula. So this will give us xy equals to cf. So this we are going to divide both sides by this matrix, so this will divide side. So when you divide this side by this matrix, you're actually going to have it in this form as e, b, d, e raised to power, which is the other way of writing the division part here. Either you write it like this, or you can write it as e, d, d, e inverse, and then c, f. Either of them will give you the same answer. So you solve until you get your answers, and the answers you are going to get will be the solution to the simultaneous equation given. Another one, 5x plus 9y equals to minus 2, 6x plus 2y is equals to 2. In matrix form, write equations in matrix form. So it will give us 5, 6, 9, 2, x, y plus 2, minus 3, 2. Let's check. 5 times x, 5x, 9 times y, 9y plus minus 2x, 6 times x, 6x, 2 times y plus 2y. So just correct. The next thing is we're going to have x, y equals to, and this will come over here, give us 5 9, 6, sure. Inverse, multiplied by minus 3, sure. So we're going to evaluate the inverse first. But 5, 9, 5, 9, 6, sure. Inverse equals to 1 over determinant, then 2 minus 9 minus 6, 5. The determinant 5 minus 6, sure, is equals to 5 times 2, 5 times 2 minus 9 times 6. This will give us 10 minus 54. This will give us minus 44. So 5, 5, 6, 9, 2, minus minus 1 over minus 1 over 44 over 2, 2 minus 6 minus 9, 5. So we say xy, xy equals to, since xy is the inverse of this matrix, we put this in place of this. That will give us minus 1 over 44, 2 minus 9 minus 6, 5, multiplied by c, minus 0 over 2, minus 3, 2. Let's multiply this part, these two parts. The x, y equals to minus 1 over 44. 2 times minus 3 is minus 6. Minus 9 times 2 is minus 18. Minus 6 times minus 3 is 18. Plus minus times minus b plus minus 6 times, oh, sorry, 5 times 2 plus 10. We're going to have minus 1 over 44. Minus 1 over 44. Minus 6 minus 18 is minus 24. Minus 24. 18 plus 10 is 28. So x, y, so we'll multiply. This will give us minus times minus 24 over 44. Here will be minus 28 over 44. Minus minus is plus 24 over 44 and minus 28 over 44. The x, y equals to 24 over 44. 44. So 4 here will give us 6, and 4 here will give us 11. 6 over 11, that will give us 6 over 11. 11. And minus 28 over 44 give us 4 here, 7, 4 here, 11. Minus 7 over 11. Therefore, x equating rows, okay, is equating entries. Equating entries, x equals to 6 over 11, and y equals to minus 7 over 11. So we're going to determine x plus y. So we're going to find the value of x, find the value of y. Again, add them together. We have 2 minus 3 minus 1, 4, x, y, x, y equals minus 1x. So xy equals to 2 minus 3, 2 minus 3 minus 1, 4 minus 1 of inverse. But 2 minus 1 minus 3, 4 inverse equals to 1 over determinant and 4, 3, 1, 2. So we're going to get determinant. Determinant is 2. 2 times 4 times 4 minus minus 3 times minus 1. So this is 8 minus 3 times minus 1 is 3. 8 minus 3 is 5. So our final is 5. Therefore, 2 matrix 2 minus 3 minus 1, 4 inverse equals to 1 over 5, 4, 1, 3, 2. So x, y is equals to, place of this here, we put this 1 over 5, 4, 3, 1, 2, minus 1, x, so x, y, equals to 1 over 5, 4 times minus 1, minus 4, 3 times 8, plus 24, plus 24, 4 times minus 1, minus 1, 2 times 8, plus 16, x, x, y, is equals to 1 over 5. Minus 4 plus 24 is 20, minus 4 plus 16 is 15. So it will give us 20 over 5, 15 over 5, x, y, x, y equals to 20 over 5 is 4, 15 over 5 is 3, equating entries, x equals to 4, y is equals to 3. So x plus y is equals to 4 plus 3, which is equals to 7. 3, 2, minus 3, 1, 3, x, y, 1, 2. So x, y equals to 2, 1, minus 3, 3, inverse 1, 2. Dot 2, 1, minus 3, 3, inverse is equals to 4 over determinant 3, 3, minus 1, 2. At this point, if you're watching this video and you don't understand why this part is like this, I would advise that you skip this video and go back to the video that treated inverse matrix or inverse of matrix 2 by 2, and make sure you understand how to solve or to get the inverse of a matrix before coming back to this video, because that's exactly what I'm doing here. So we proceed. The element is 2 times 3 minus 3 times 1, 6 minus 3 times 1 will give us minus 3, 6 minus x minus is plus, that's 9. So 2, 1, minus 3, 3 inverse equals to 1 over 9, 3, 3 minus 1, 2. Okay, that is so come here, see x, y, equals 4. So where we have this, you know x, y is equals to inverse of this matrix. This matrix, the inverse of it. So, and the inverse of it is this part. So we put this in place of this here in this expression. 1 over 9, 3 minus 1, 3, 2, and 1, 2. So we evaluate these two matrices. 1 over 9, 3 times 1 is 3 plus 3 times 2 is 6. Minus 1 times 1 is minus 1 plus 2 times 2 is 4. 1 over 9. 3 plus 6 is 9. Minus 1 plus 4 is 3. 3. So this will. So since it's a scalar, you multiply this by the entries in this matrix. This will be 9 over 9 and 3 over 9. Okay. So x, y is equals to 9 over 9 is equals to 1. 3 over 9 is equals to 1 over 3. Equating entries. Putting entries x is equals to 1 and y is equals to 1, 2. So if matrix E is equals to 3 minus 4, 7, 2. What is the one? Find A inverse. A inverse equals to 1 over determinant A over 2 minus 7, 4, 3. The determinant A 3 times 2 minus 7 times minus 4, 6 minus 7 times minus 4 is minus 28. 6 minus is minus is plus 28. 28 plus 6 will give us 34. So A inverse is equals to 1 over 34. 1 over 34. 2, 4 minus 7, 3. Says compute A dot A inverse. A dot A inverse means multiplication. So matrix A is 3 minus 4, 7, 2. A inverse is this. So since it's a scalar, we multiply the scalar by the matrix. So this will give us 2 over 34 minus 7 over 34, 4 over 34, 3 over 34. 3 times 2 over 34 will give us 6 over 34 plus 7 times 4 over 34 will give us 28 over 34. 3 times minus 7 will give us minus 21 over 34. And minus 4. 3 times minus 7 will give us minus 21. 7 times 3 will give us plus 21 over 34. Minus 4 times 2 gives us minus 8 over 34. 2 times 4 plus 8 over 34. Minus 4 times minus 7 minus 20. Minus 4 times minus 7 gives us plus 28 over 34, and 2 times 3 give us 6, that's 6 over 34. So minus 6 plus 6 over 34 plus 22 over 34 gives us 6 over 34 plus 28 over 34. Denominator is 34. 34 into 34, 1 times 6, 6. Same thing here. 6 plus 8, 6 plus 28 is equals to 34 over 34, which is equals to 1. And this is 1. So minus 21 plus minus 21 over 34 plus 21 over 34. LCM is 34. Minus 21 plus 21. Add 0 over 34, which is equal to 0. Equals to 0. Minus 8 over 34 plus 8 over 34 is equals to 34 minus 8 plus 8, 0 over 34, which is equals to 0. And 28 over 34 plus 6 over 34 plus 10. 34, 28 plus 6, which is 34 over 34, which is 1. This goes to 1. So you see that when a given matrix is multiplied by its inverse, the result is identity matrix. So we say therefore A dot A inverse equals to identity matrix. Come on to the theory. It says hence using inverse method as x equals to A inverse B, solve the equation this form. So x here represents this part here. A inverse will be when you bring this part to this side, it becomes inverse, and B represents this part. So we're going to solve. Then we'll solve in that form. Our final answers will be the values of x and y. So 3 minus 4, 7, 2 x y is equals to minus 1 and 1 minus 1 and 1. So x y equals to 3 minus 4, 7, 2 inverse minus 1, 1. But 3 minus 4, 7, 2 inverse equals to 1 over 34. 1 over 34, which is this value here. 1 over 34, 2, 4 minus 7, 2, 2, 4 minus 7, 2. So next thing is to x, y is equals to 1 over 34, 2, 4 minus 7, 3 multiplied by minus 1, 1, which is 1 over 34. 2 times minus 1 minus 2, and 4 times 2 times minus 1 is minus 2, minus 7 times 1 minus 7, 4 times minus 1 minus 4, 3 times 1 plus 3 is equals to 1 over 34, minus 7 minus 9, minus 4 plus 3, 1, minus 7 minus 9, minus 4 plus 3, minus 1. X, y equals to x y is equals to 1 over 34 minus 9 minus 1, which is equals to. You can leave your answer like this in matrix form, or you simplify, or x y is equals to minus 9 over 34 and minus 1 over 34, which also implies that x is equals to okay, which implies that x is equals to minus 9 over 34 and y is equals to minus 1 over 34. So either the answer can be left in this form or it can be left in this form. So same thing. We can as well just clean up this line so it doesn't look confusing. So from here we go to this point.